Back to Everything Swift. Today we will be tackling Leetcode question 34. Find the first and last position of element in a sorted array, right? So we are given an integer array here that is sorted in an ascending order. We're supposed to find the starting and ending position of a target value that is given in this parameter here, right? If the target is not found in the array, we return -1, -1. You must write an algorithm in olog and runtime, right? So let's take a look at this example here. We are given this array here, which is this nums integer parameter, and the target is 8, right? And the output is 3 and 4, which is the starting is 0, 1, 2, 3, right? 3 and 4, and then that's why the answer is index 3 and 4. So basically, we're supposed to just find the target inside this integer array and find the starting and ending, which so happens to be 3 and 4 in this example. And if the number doesn't exist, we just return -1, -1, right? Okay, so quick hint here is that this answer has a lot of hints given to us. Like the first thing is the ascending order tip here, right? So we know this numbers array is sorted, right? That's one key tip that we get from this question. The second one is O log n runtime, right? Uh, Usually when we get a question that is saying that it's a sorted array, right? Uh, the first thing that should come to mind is that we should explore binary search as our potential solution. Most of the time, that is the mechanism that we need to use to solve the problem, right? And it's the same for this question as well. We will be relying on binary search to solve our problem. And yeah, so let's just jump right straight into the code and I'll show you how it's done. So I'm just going to do a quick boundary check here. If nums is empty, and we'll return -1, -1, right? So this is just an optimizer check here. If in the event this integer array is empty, we do not have to process anything below it, so we can just exit it as fast as possible, right? But it is quite strange in the Leetcode world that they'll give us an empty array in this question, unless it's specified here, which is shown in this example here. So um, yeah, but I think in the real world, we just need to be extra careful and write the most performant code that we can. So this is the statement here. And let's see. I think we have to do a little bit of recursion here with the binary search involved. So I'm just going to create a separate function here, and I'll just call it check, which will take in a parameter of the integer array, the target of type int, and the starting and ending, right? Which is pretty common for a binary search question, right? Start and end is required to calculate the midpoint that is required in the formula of binary search. So that's why we're going to pass it from here. Check nums, target is target, and start is 0, and end is basically the entire array. So nums.count -1. -1 is because we are dealing with a 0 base index, so we are just minusing 1 here. Okay, so just a quick boundary check here. If start is bigger than end, that is not good, right? There's no way it is a valid thing when the starting index is bigger than the ending index. So it's just a boundary check. We should exit and it should never happen, right? Then let's go and calculate our midpoint. This is where the binary search mechanism kicks in. So start n minus start divided by 2, right? And then we get the mid value, mid val, which is nums of mid. Okay. So why do we do this formula, right? Why not just like n minus start divided by 2? So basically there are some things involved with integers where we might encounter an overflowing issue. So this formula is just to sort of like mitigate that scenario of integer overflow, right? And this is our mid value. Okay, so what we're going to do here is check if mid val equals to target, right? That's scenario number one. This is the part where we'll find the range, right? Because we have found the matching target. But in the event that we did not find the matching target, but the mid value is bigger than the target, right? And then another, else if. And the last scenario is where mid val is smaller than the target, right? So if mid val is bigger than the target, right? Let's take a look at this example, right? The mid val, and just imagine that the target is 7, right? And the mid val is 8. So we know the target is always on the left of the mid val, right? So what we can do is we need to move our ending range here, our ending parameter, to be towards the left, right? Which would be mid minus 1, because we know for sure that the target is on this side. It's not on this side, and and because we know that mid val is bigger than target, we don't have to include mid val as well, right? So we're just going to update our boundary here. Nums target start remains the same. Here is where we put mid minus 1, right? So imagine the target is 7, mid val is 8. So we are just moving the ending point to be here, right? So this operation the recursion happens when it calls check again, but this time the boundary is changed, right? It's no longer nums.count minus 1, but it's mid minus 1, right? So it will only perform in that particular range. Okay, so it's the same thing for when the mid val is smaller than target, right? We are going to update the boundaries as well, but the difference is that it has to be mid plus 1, right? And the ending remains the same. This one should be start, sorry, right? So mid plus 1, because like imagine again, the mid pointer is 8, and let's say the target is 10, right? We know the target is bigger than 8, right? So the target number will never be anything less than the mid value, right? So we're just moving the starting boundary to be at the appropriate position, and then we re-perform this binary search mechanism again, and hopefully we will enter this if condition where the mid value matches the target. If it doesn't, it should exit the -1, -1. This which is what we return if we can't find the matching target, right? So I hope it explains what this else if and else does. We're just updating the boundaries of our binary search so that we can try and get to find the matching target, right? So now the third scenario is when we found the matching target, what do we do, right? So I'm just going to create start range equals to mid, right? And var end range equals to mid. Now, while start r is bigger than equals to 0, and nums of start r equals to target, okay? What do? We just decrement it. And then the same thing for n, but only thing is we're going to increment it, right? If nums.count minus 1 and nums of nr equals to target, nr plus 1. I'm just putting start r and r just to represent the word range. I don't want to type it out, but this is just a short form, so nr. So in the end, we'll just return start r plus 1 and r minus 1. Okay, so let's see what's going on here, right? When we found the mid value equals to target, right? So in this scenario, mid val is 8, for example, right? So we want to find, like, is this the starting point, or is there an 8 before it, or could it be potentially there is another 8 somewhere else, right? And it's the same thing for the end range, where could the next number be also 8, right? We're trying to find the entire range, right? So what we're doing here is once we found the midpoint, for example here, what we're trying to do is expand it out, right? So the starting range, obviously we have to go left, right? Hence we decrement it, right? And then we were trying to find where does the range stop, right? So it could be here. In this example, it stops right here, but imagine that this 10 is also an 8, right? So we want to keep this loop going, and that is the final range, right? So basically, we're just expanding on both sides, the left side and the right side, to find the starting point, starting range, and ending range, right? So we are doing like nr equals to less than equals to nums.count minus 1. It's just a boundary check because we are performing a while loop. We can end up in index out of bounds scenario. Same thing with start. We're just checking bigger than equals to 0 because we are going to the left, and nr is less than count minus 1 because we're going towards the right. We don't want to exceed the minimum and maximum limit while we check, right? So the reason why we are doing start r plus 1 and nr minus 1 in the end is because if we look at the while loop operation here, we are checking it to be equals to target. That means there will be a scenario where when this while loop exits, we are including a numerical number that is not equals to the target, and we need to get rid of it. So in this event here, we will get like uh, after these two while loop, before this return statement, we will include using this example here, we will have the range as 7, 8, 8, 10, right? That's when the while loop exits. So uh, when we do start r plus 1, we are dropping the 7, so it's 8, 8, 10. And when we do nr minus 1, it basically becomes 8 and 8. And that's how we get 3 and 4, right? So let me just print this out so that we can see it clearer, or what I meant by that. Uh, okay, let's see here, and r. And I think that should be it. -1, -1. Looks good. Let's try. There we go. As you can see here, 2 and 5 is the range, the index range, right? So if we take a look at this example here, 0, 1, 2, right? It includes 7, but that is when this while loop breaks, right? Because now start r is 7, but the target is 8, right? So it breaks out from this loop. So and the same thing with nr, right? So 0, 1, 2, 3, 4, 5, right? It includes the 10, right? So is nums of 5, which is 10, equals to 8? No. So that's why it breaks out. Um, and yeah, that's why we need to do the plus and minus 1 here to drop those numerical value that doesn't equals to the range, right? So I hope that explains it. Let me just try and submit this since we passed the test case. Let's go. And there we have it. That is the solution for this question on how I attempted it. So hopefully this video solution is helpful. And as always, if you find my video content helpful, please feel free to subscribe to this channel. I'm trying to grow this channel, and I'll be putting more video content like this in the near future. So as always, thanks for your time, thanks for your support, and thank you. Bye bye.